All right, well, hello, everyone. It is so wonderful to see you. My name is Carter Zenke, and I am the course's preceptor. I'm joined here by all of you all. So what we do is just take a minute to unmute and do something unusual for Zoom, which is say hello all at the same time. So on the count of three, I'd like to invite you to unmute and say hello. We'll count 1, 2, 3, and hello. Oh, amazing. So it's good to have this nice chorus of voices here today. Everything we'll do today is here at this URL right here, carterzenke.me/section. You'll find all of the slides we'll work on, the exercises we'll work on together. If you'd like to get in touch with me in particular, you can email me at carter@cs50harvard.edu, and feel free to email me there. So I thought we'd start off with is just a kind of refresher on lecture. And so I invite you to think back to 2 questions from this week's past lecture. The first is, what did you find exciting from lecture? What are you interested in? And next is, what are you still confused about? Or what do you still have questions about? So take a minute to think about those 2 questions. Again, what are you excited about? And what do you still have questions about? And we'll come back in maybe 30 seconds or so and share out a few of these ideas here. So we'll come back in 30 seconds.
Need to close your eyes, it's you and I. Let the time pass on by, we don't care about the others. Let's stay dancing all night, cause I know you're my lover. Ooh, baby, I love it, and I can't ignore it. I like and you can notice, my body gets scary, alright. I don't wanna be sad, you know that if you offer me, alright, and I don't wanna leave. So tell me, baby, what should we do? That's right, we have feelings high. So
All right, so I think that'll be enough time to do some thinking on this past lecture this week. I hope you might do a few warm, cold calls to get a feel for what we're interested in, what we're kind of wondering about this week. So if you wouldn't mind, I go to maybe Alina and ask you what you find exciting, what you are still wondering about this week.
So I think this week, something that was pretty interesting was, I thought the section about like debugging was pretty interesting. I definitely had to do a lot of that for my PSET. I'm not really wondering so much so far, I think.
Nice.
I think we kind of just getting intro to things, but yeah.
Yeah, that's good to hear. So some interest in debugging and how we do that well. I think we'll do a little bit of that today in section. We'll write some programs and hopefully debug the errors we'll find in them. And maybe could we go to Dewey, if you don't mind? Maybe it's something you're interested in or things you're wondering about.
Yeah, no problem. I guess like the most interesting thing from the lecture this week was actually the command line arguments. So I've programmed before, but I've never actually used command line arguments like in a program that I've made. So that was actually really cool. And then what I'm looking forward to, I guess just working on some more complicated assignments, because those tend to be quite fun. So yeah.
Yeah, very cool. So we saw command line arguments, which again are kind of these inputs to your program that we can type in the terminal itself before your program runs. And those then decide how the program will run, gives it some options to work with as it runs. Just a few questions for us here today as well. Something we'll talk about in section today are, what are the steps involved in compilation? So we take this source code, this code written in C, and convert it to binary, but how do we do that? And why do we do that? We'll dive deeper into arrays. What are they? Why would we use them? We'll talk about strings, particularly in the context of arrays. And finally, to Dewey's point earlier, we'll talk about command line arguments as well. And throughout this, we'll hope to sort of figure out what makes for good design. In this course, we'll talk about correctness, which is, does your code work, but also about design, which is how well does your code work. So we'll figure out what good design looks like in a few different contexts here. To kick things off with compilation, though, we saw this program in lecture, if I can go to full screen here. And can I have somebody just shout out, what would this program do? If I were to run this program, what would you see on your screen? Maybe could I ask McKenna, if you don't mind? Do a warm cold call.
Sure, yeah, you would just see hello world.
Yeah, just see hello world, right? And go back to this here. Now, if we were to compile this from C to machine code to binary, we'd have a few steps along the way. So we saw this in lecture. We saw that this source code first gets converted to assembly code, this kind of esoteric language here that isn't quite binary, but is almost there. And in the next step, we end up getting down to this binary that your computer actually runs. So we have this maybe hello.c file that then gets converted to this regular hello file that's written in binary here. And to do this, we have this program called Clang, or C language compiler here. And if we were to run Clang like this, we would probably need to provide a little more context for Clang, because Clang wants to actually take some source code and convert it to machine code. But here it wonders, what source code should I convert to machine code? So we might use an example of a command line argument here and actually tell it what we want to convert. We could take clang hello.c to tell it we want to convert this hello.c file down to binary. But we could also be more specific. We could say, I want not just the a.out file we would get from this we saw in lecture, but more specifically a file called hello. So I could say clang-o and then hello to say this is the output file I want. And then finally the hello.c file that I actually want to compile from source code to machine code here. And all of this can get a little bit complicated. Like this isn't the full kind of command we need to compile all of our CS50 programs. We might want to link in some libraries, and there's a lot of other things you might type here to make your compilation successful. So what we've done is we've given you this command called make that sort of simplifies a lot of that for you. So make kind of runs in the background, Clang along with a lot of options behind the scenes to compile your program to binary ultimately. But in this class, and even if you do more programming in the future, you'll probably use a command called make to simplify that and keep yourself from typing all this stuff in the terminal as you go. Now, what questions do you all have on compilation or on converting from source code to machine code, if any? All right, so seeing none here, I imagine you've gotten to do this a little bit so far in the class. So let's dive a little more deeply into arrays now. So if we talk about converting source code to machine code, we're kind of getting down to like the low-level details of computer. And arrays themselves are kind of the most basic data structure we can have, the most basic way we can organize our data. So I'm curious to hear your thoughts on what is an array? What would you define as an array? And could we go maybe to Bianca, if you don't mind? What in your mind is an array?
Okay, so this was the most confusing part of lecture for me.
Nice.
But I think it compiles like, it's like smaller pieces or like elements. So it compiles all the elements into like essentially like so that they're like all next to each other. And it also like sorts, for lack of a better term, like elements of the same value so that they're next to each other.
Yeah, so I like a few things about what you said there. So I like that you said that it combines these elements, these pieces of data that we have, and it puts them like back to back in memory. So let's take a look at an example here. One CS50 final project was this one called CS50. And the goal of this project was to actually store the number of hours somebody has slept every day. So somebody might come back to this application and type in, I slept 8 hours last night. They come back the next day, they type maybe 9 hours or 7, depending on how much they slept. And if we wanted to store this data, at least currently in our stories so far, we would need a whole bunch of variables. We'd have to say, okay, I need hours 1, I need hours 2, hours 3, and so on as I were going through the days here to store all of this data. But what is not so well designed about this? Where would this go wrong? And maybe could I ask Alina, if you don't mind?
I'm not too sure.
Okay, so we're trying to store all this data, right? And if we had to keep track of all of these variables, let's say I wanted to have like a 6th day of hours, what would I have to do now?
You have to add another line.
Yeah, add another line and presumably like another variable, right? But that would get pretty messy pretty quickly, because assuming I want to keep track of maybe like a whole year's worth of sleep, I wouldn't want to have hours 1 through hours 365. That would just be a whole lot of individual variables, right? And so to Bianca's point earlier, these arrays help us keep track of this information kind of all in one piece. So let's take a look at an example of an array here. Here we have one called hours. And as we're thinking about these arrays, this really good mental model is this like kind of long line of individual pieces of data. So here we have those same 5 hours, but now under kind of one block of memory that we're going to call hours. And when we're trying to create this block of memory, there are really 3 things you're going to need to take care of first. So the first one is the name of this block. Like, what are we going to call this array? So here we're going to call it hours. And maybe I'll turn over to you all for the other 2 that might matter here. We have a name for the array, but what else do we care about if we're going to try to create this block of memory? Could I ask maybe you, Dewey? Yeah, go ahead.
You would need the length of the array. So here we would probably want 7 because there's 7 days in a week.
Yeah, so probably 7 days in a week. So we could make maybe this array of length 7 to store 7 hours of sleep every day. In this case, we'll probably just go with like a weekday kind of calendar. So we'll have 5 in this case. But the size is certainly something we care about here. And there's one other thing we care about too: the name, the size, and what else would we need? Could I maybe ask you, McKenna, if you have any ideas here?
I'm honestly not sure.
No, it's okay. No worries.
This was like a topic from lecture I was a little confused on.
Yeah. Other thoughts here?
Type of like value.
Yeah, totally. So we need the type that we're actually storing here. So 3 things we care about for arrays when we make them: the name, the size, right? How many elements are we storing? And then also, what kind of type are we storing in this array? And the type matters because we want to know how much space to allocate to our array. Different types have different numbers of bytes that represent them. Like an integer might have 32 bits, or maybe 4 bytes in that case. But maybe just a character would have only 8 bits or 1 byte. So the type matters for how much memory we're going to allocate to our array here. So with this in mind, we keep in mind the name, the size, the type. We have some syntax we would use in C to actually create this space for the array. And this is what that would look like here. Up top, we have int. And what would int represent in this case? Could I maybe go back to you, Dewey? What would int represent here?
Int would represent the data type of the stuff stored inside the array. So we're storing integers, so we want int.
Yeah, nice. So similarly to how we declare our variables with the type first, similarly for our arrays, we say, what type do you want to put in this array first? And then next is the name of the array, so hours. And then what is inside these brackets? Maybe could I ask you, Bianca, do you mind telling me what's inside these brackets? What pieces of the puzzle is that?
That's the size of the array.
Yeah, it's the size of the array, right? So here we're saying we have an array called hours that will store integers, and it'll be of size 5. So we'll store 5 integers. And this is all well and good, but one thing we need to keep in mind is that our array isn't quite useful unless we can access individual elements of the array. So we have this syntax that also uses this bracket notation, and we can see it a little bit down below here. So if we wanted to get the very first element of our array, we'd say hours bracket 0. If we wanted to get the next one, we'd say hours bracket 1, and so on. And all the way at the end here, we have hours bracket 4. But why would we not have hours bracket 5 to get that kind of last element there? How does that make sense? Maybe Alina, would you have any thoughts here? Or McKenna, I see your hand raised.
Well, since we start from 0, like if we want 5 pieces, if we count all the way up to hours 5, then we actually have 6 pieces.
Yeah, totally. So if we counted from 0 to 5 inclusive, well, that's actually 6 elements, but we only have 5 in our array, right? If we start from 0 and count up to 4, well, that's 5 distinct elements. And so that is the length of our array, meaning we're not going beyond the length of our array here. And if we wanted to go ahead and add some data to this array, it would be kind of simple assignment. So here I might say, I want to put 7 in the very first array spot. Hours bracket 0 gets the value 7. Remember, we read this equal sign as like a get kind of in English. And then we could say, okay, well, hours bracket 1 should get the value 9. and so on and so forth. And so we kind of fill up our array as we go. Now we could fill up the entire array at once if we wanted to, and not to have all these lines of code here. We could do this. We could say, let's create this array named hours that has 5 elements, and let's have it get this set of numbers here, 7, 9, 8, 7, 8. And overall, that would give us the entire array filled up for ourselves here. And even then, we might not even specify the size in this case, because we know, well, there are 5 elements over here. So we could just have C infer how much space our array takes up. We could take out that 5 there and say, well, we just have these 5 elements here. We'll make sure we have an array of size 5. So I just wanted to pause here for any questions you all might have on this array syntax or how arrays are working here. All right. So seeing none so far, let's keep going then and get to an exercise in just a bit. One thing we might want to do with our arrays is, again, access each element. And sometimes we'll want to start at the very first element and then kind of keep accessing things as we go through. And a for loop is a great way to do that, because a for loop lets us sort of specify a variable that can increase, and we can then use that variable to access individual parts of our array. So here I might have the same array, hours, up at top, and now this for loop here that is starting at I equals 0, going up to, but not including, I will be equal to 5. And then we'll go ahead and print out whatever is at hours bracket I here. And so a question for the group now is, what would this print out if I were to run this? What would I see on my screen? Feel free to raise your hand if you'd like. What would I see on my screen if I were to run this for loop? Yeah, Dewey.
You would see 7, and then a new line, 9, new line, 8, and then onwards until the end of the list, or array, technically, yeah.
Yeah. And I'm curious, you said a new line. So what is indicative of the new line here?
There's a /n, so that means that tells the computer to start a new line.
Right. So in this print statement here, we have that %i, which is like a placeholder for an integer that we'll print out. And we'll specifically add in the hours bracket I integer there. And we'll make a new line here to say, OK, once you're printing that integer, let's go to a new line, print that one, go to a new line, print that one, and so on and so forth right here. OK, so with that in mind, let's go ahead and try an exercise in small breakout rooms here. And this exercise is called powers of 2. So the goal here is to make an array that has a certain size, maybe given to us by the user. And then we'll want to create an array where every element is 2 times the previous number. And we can start the array at this at 1. So we might have an array like 1, 2, 4, 8, 16, 32, and kind of increasing by 2 times every time we go through and add this new element here. And let's go ahead and get started on this one together. So if you want to go ahead and pull up code.cs50.io, that would be great. And you can follow along over here while mine boots up as well. And what we'll do once your code space loads is create this file called array.c. You go ahead and make this program where we'll have this array that will be every element 2 times the previous one. And just to kick us off here in a discussion, what kind of boilerplate code would we really need here? And by boilerplate, I mean like default code we want to have in every program that we write. Maybe at the top of our file, what's the first thing we would do here? Could I ask maybe Sultanali, if you don't mind? What would we have to have at the top of every of our programs? And I'll have mine booted up here. So what we want to do very first is make sure we have our program up. So we can type code array.c, and that will make sure we have this new file called array.c. And that .c is important there. That means this is a C file. And now at the very top of our programs, what we're going to need, can I maybe turn to Alina, if you don't mind? What would we want to incorporate at the very top of our file in most programs we write?
You would have to include like from like either the packages, like the from like CS50 and like SD. I forgot it, but
Yeah, you're totally right. So we want to make sure we include some libraries or some packages, perhaps, in our program, because we want to actually use those functions in our program. So we might first include the CS50 library by typing #include CS50.h. And we might also want to include the standard IO library for standard input and output, meaning some functions we can use to get user input and then print something out to the screen here. All right. And then what else would we need? Kind of template here. What kind of function is going to be the core part of our program here? How would we do that? Could I ask McKenna?
I'm so sorry. The core part of our program, we would need like int main void, right?
Yeah, totally. Int main void. So I could type int main void here, and then have this to sort of delineate where I'm going to type the rest of my program inside of these curly braces here. And we'll see why, in particular, we type int main void just a little bit. We saw it briefly in lecture too. But for now, we want to make sure that we're going to get some user input. So I might have you all finish this part together before sending you off to work on the actual array building piece. But what kind of function would we use to get user input in this case? We want to get a number that we could use for the length of our array. So what kind of function have we seen in CS50 that could help us with that? Do you mind if I ask maybe Bianca if you have an idea or maybe some steps forward for us?
Can you repeat what you said? I'm sorry.
Yeah. So we want to make sure we have user input to get the length of the array. So what kind of function could we use to get a number from the user that we've maybe seen so far?
A number you said?
A number.
The get int.
Yeah, get int. So we could say, I want to maybe create the length of this array, and I want to make sure I get an int from the user, maybe prompt them for a length, right? And here's a question of design. What if the user types in a negative number? Well, I can't have a negative length array. So I should probably do my best to make sure they give me a good number and not assume that they're going to cooperate. So I might do this. I could say I want to make sure that I get the length from the user here. And I'll make sure to declare my variable up above. But then before moving on, I want to make sure that this length is definitely going to be at least 1. So I'll say if the length is less than 1, I want to reprompt the user as we go through. This just ensures the user doesn't type in like -1 or 0, like values that are invalid for our array length, right? Okay. So we have some initial code here, and feel free to maybe jot this down on your own array.c file. What we'll do next is we'll sort of break out into a few rooms, and we'll come back in maybe 5 minutes or so. But the goal here will be to finish this prompt here. So you're going to create an array that is of size whatever the user typed in, and then we'll make sure that every number is 2 times the previous one. Yeah, Dewey.
Would it be possible for you to copy and paste like the prompt into the chat so that we have it like on hand?
Absolutely, I'll make sure to do that. Yeah. All right, so let me go ahead and type that in the chat. But once we do that, I'll send you all to breakout rooms and come back in maybe 5 or 7 minutes or so.
Can I ask you a really quick question? Is there
Yeah, go ahead,
like,
McKenna.
because I know like for the lab, we had like a folder that we unzipped to like in VS Code. Is there something like that for the section, or should we just create our own file?
Good question. Yeah, so normally for like a problem that you're working on in the problem set or a lab, you might download a file, unzip it. Here, we're just kind of making our own file. So if you want to, you can go to your terminal down below, just type code array.c, and that should make you this new file. You can type in your code as we go.
Okay, thank you.
Yeah. So let me type this in the chat. So we'll create a program that prompts the user for a size. And then we're going to create an array of that size where each element is 2 times the previous one. And you can start the array at 1. And your goal is to ultimately print the array kind of integer by integer. All right. So I hope that's helpful. I'll send you all into breakout rooms in just a second here. We'll come back in, let's say, about 5 minutes. Okay, welcome back, everyone. I hope you got the chance to make at least some progress here, but no worries if you didn't get all the way there. What we'll do now is sort of work on this together a little bit. So here I have, go back to my view here, where we left off in our program. And again, the goal was to make this array where every element was 2 times the previous one, and it had the length of whatever the user gave us in this case. So going back to some of the slides and that we just talked about earlier, how would we even declare or make space for this array in our program? We want to have an array that stores integers of a certain size and a certain name. And maybe could I have Alina, if you don't mind, you want to propose our array name and length and what it stores?
So for the type, it would just be int, I think.
Yeah, exactly, storing integers.
As for the size, I think the size would need to be like the user input.
Yeah, definitely. So be the variable length here. And before we can give it a size, though, we have to give it a name. So do you want to propose a name for us?
I don't really know what you would name it, but
Yeah, I mean, it could be anything. We could
uh,
call it, well, for fun, we call it twice, like twice the previous number. But you could also call it array, you could call it whatever you want to call it. Here we'll say it has a certain length, and that length is literally this variable length here. So whatever we type in, that'll be the length of our array. Now, if we wanted to go through every element in the array, what kind of loop might we use here? We want to go through every element, and we want to make sure that we set each of those elements equal to some number. So what kind of loop could we use? Could I ask maybe Bianca if you might have some thoughts here or ideas?
I want to say a for loop, but or maybe another do while loop. Unsure.
Yeah, so your for loop is the right intuition. And why is because if we kind of know how many times we want to do something, like we know we want to go through every element of the array and it's like a fixed size, a for loop is great because a for loop can do something a certain number of times. So here, let's say I want to loop from maybe I equals 0 all the way on up to I is less than length and increase I every time I go through. And so here's what that looks like here. And the goal here is maybe we're accessing every element of twice, right? By going from I is 0 all the way up to I is not length, but 1 less than length, right? So it goes to every element inside of twice. But what should every element inside of twice be? How would we complete this statement here? It should get a value, but what value should it get? Could I ask maybe McKenna if you have any ideas here?
Sorry, could you repeat the question one more time?
Yeah. So we're just trying to figure out what number should we put into kind of each element of this array called twice. We know that we want it to be 2 times the previous number, but how would we actually kind of put that in code if you have any ideas here?
2 times I minus 1.
Yeah, nice idea. So we could say 2 times twice I minus 1. And what this is going to do is say, OK, let's make sure that the current space we're looking at inside of twice is going to be 2 times the previous value that's in twice here. So for example, if I is 1, then we'll look back at 0, index 0 here, multiply that by 2, and make that the value of twice at the index 1. So let's go ahead and try running this. If I type make array, let's actually try printing out this value as we go too. So I'll say, not only do I want to set the value, I want to print it out as we go. So I'll say %i, and then twice bracket I. I'll then recompile my program, and I'll do /array, maybe of size 5, but I get just zeros. Any ideas about this bug in our program? Yeah, Dewey.
Wait, sorry, I had to unmute. So essentially, we need to set a value for the first element in our array. Otherwise, it's just going to take 0 and then just like multiply it by 2, which is obviously 0.
Right. Yeah. So we need to sort of set a first element here. And more specifically, what's happening is, let's say I is 0, right? Well, okay, twice bracket 0 should be 2 times twice bracket -1. And so -1 will look one space in memory before our array. And really, who knows what's there? It could be 0. It could be some random number. If I were to try rerunning this program, I might get a different answer. Still 0. Rerun this again. Still 0. But we might get some random number there eventually, because we're not really sure what's one space memory before our array. So to Dewey's point, let's actually first set twice 0 to 1. That first element of twice, set it to 1. Then we'll go ahead and start from I equals 1 and look 1 behind us, multiplying that by 2 as we go through. So I'll do make array. I'll do /array of size 5. And now I get something that looks pretty good, but I don't think I have the full array here. What else do I still need to do? To go back to my terminal, I only see 2, 4, 8, 16. Any thoughts, Dewey, if you want to finish the debugging here?
Wait, give me a second. Let me just pull up.
Sure.
Okay, so we're not seeing the entirety of the array. So we're only seeing up till the last 4, even though we want 5. So it's not showing like the 0th element, which is 1. So
Yeah.
we should print f twice 0, for instance.
Nice. Yeah, so we got to print it out here as well. So I'll say print out whatever's in twice 0 right after we set its value there. So basically, we're going to fill in the very first element of our array on lines 15 and 16. Then we're going to fill in the rest of our array on lines 18 through 22. So now if I compile this, make array, I'll run array, and now I'll see every element inside of that array. So what questions are there on this program or arrays in general? Any lingering thoughts or questions?
Could you go back to where you had like after int twice length, like the line of code you have after that, and like explain that if you don't mind? Thanks.
Yeah, totally. So here, let me actually comment the code just to make it a little clearer. So here we're going to get the length from the user. Now, once we have that length, we're going to declare our array, which means like make some space for it in our computer's memory. And here what we're doing is going to set the first value. So our array should start at 1. And so we'll take the very first element inside of twice using that 0 index here, because remember we start from 0 and go on up. We'll say that gets the value 1. I will then print out that value, right? And then we'll look at the rest of our array. We'll start at I equals 1 instead of I equals 0 here. Move on up through the length, increasing I as we go. And as we do it, let's go ahead and make the current element twice the previous. And then we'll print out the current element. Does that make sense? Nice. Other questions on this one? All right, so let's keep moving in that case. And our next topic, kind of following through on arrays, is this idea of a string. And what are strings really? We kind of saw this in lecture a little bit. Strings are kind of these collections of characters, like a name, like Carter, or maybe a location, like Harvard. But what kind of data structure are they really? Maybe could I ask Alina if you have any thoughts or guesses here?
From like what I understand, I just thought of strings as like, strings of characters instead of just like one character.
Yeah, totally. So a string is like a string of characters. We've kind of taken some individual characters and like strung them together, so to speak. And this name comes from the fact that we have some characters now like all grouped together. And so similarly, how we had these hours that were previously like individual variables, but now I put them in this array called hours. We can do the same for strings. We're taking these individual characters, putting them together into this one big array here. So if I take a look at this string is Emma. And if we take a look at the entire string, we'll see it's basically the same idea as an array. We have this name for the array. We have some elements inside each individual block of that array. And we have that same syntax to get access to individual elements of that array. So name bracket 0, name bracket 1, and so on. But what's kind of special about this string here? If we take a look at that last element, does anyone remember what that last element was called? Just to show you again, looks like a /0. What was that called?
Wasn't it the null character?
Yeah, right. It was the null character. And do you remember what its purpose was? Yeah, maybe go ahead, Dewey. Yeah.
It marks the end of the string.
It marks the end of the string. So otherwise, we wouldn't really quite know where to stop if we were looking at a string. We have to have some way of knowing, OK, this is the end of our string now. But here we have this null character to tell us, OK, that is going to be the end of our string. If we wanted to sort of make this same string, we could do so by making an array of characters. So here we have up above this array called name, and it's full of characters. And we've given it some elements here, E, M, M, A, and that null character. So we've kind of composed this string ourselves, kind of from individual characters. And this syntax here, string name gets the value Emma, is kind of some sugar that we've given you to sort of make it easier to declare an array. This is kind of based in the CS50 library. But on your own, if you were off into the world and program in C more generally, you might make strings a little bit more like this. Or you might use some libraries to simplify things for you. But basically under the hood, this string is this array of characters. And notice similarities here between this array called name and this array called hours. It's much the same thing, just here we're storing integers versus storing characters. That's handy because we can do all the same things we could do with arrays earlier. We can have like name bracket 0 to get that first character, name bracket 1 to get that second character, and so on. And so just curious here, any questions on strings or how they're similar to arrays or the syntax that we've seen here?
Sorry, just one quick question. You
Yeah.
can't like circle through a string in the same way you can with an array. Like in a string, you couldn't say like the first character with like square brackets, first character, like square brackets 0 and then 1. Like that's unique to arrays.
It's unique to arrays. Like arrays are the only data structure that have that bracket notation. But the nice thing about a string is a string just is an array. So you can get that same functionality. So here, even if we didn't do this, we didn't spell out the array like this, we just did string name gets the value Emma, we could still do this syntax, like name bracket 0 gets that capital E at the beginning, name bracket 1 gets that second character, that M there, and so on. Does that make sense? Nice. Other questions too on these strings? Okay. So one of the interesting things about these characters is that they're represented ultimately by binary. Everything in the end is. But in C, we have this kind of representation, dual representation of characters, where this capital A is represented by the number 65. Lowercase a is represented by the number 97. And somebody came up with this, the American Standard Code for Information Interchange, I believe. I'm not misremembering there, or ASCII. And so ASCII defines these relationships between these characters and these numbers. And the interesting thing is, if I were to go to my code space here, let's say I wanted to make a file called string.c. I could include all the files I need, like this. I could make my main function. And let's say I did have this string called Emma. Well, what I could do is I could print out every letter of Emma like this. I could say for int I is 0, I is less than, well, how long is Emma? How many characters should I go? We don't I mean, you could look at it and say it's 4, but there's a better way to do it. And we saw a function in lecture. What could we do? Yeah, Dewey?
strlen.
Yeah, we need strlen. Strlen is this function in the string.h library. We might say strlen, kind of for short here. And we want to get the length of our strings. We could say this new variable called length gets the length of name. And now we can kind of finish our for loop. We could say I is less than the length of that string, I plus plus, it's increasing by 1 as we go. And now we'll say, okay, print out for me whatever character is inside of name bracket I. And so if I were to make this, compile it to machine code, I could run /string and I see EMMA, right? All of these individual characters. But what I could do too is I could say, I want the integer representation of this. I want to print this as an integer. I could recompile this. And let me actually add this new line at the very end of my program now. I could say make string and then /string. And now I don't get EMMA, I get 69, 109, 109, 97, right? So whenever you're working with characters, you can also treat them as numbers. And we can do this kind of interchangeably as we go through. Like I could say, is a certain number, or is a certain character more than or less than some number, or things like that. And this will be useful for us as we work on this next exercise here, where we're going to try to figure out if a string's characters are in alphabetical order. So what do we notice here if we go back to this ASCII chart? We look down at this lowercase half. What do you notice as the numbers get further in the alphabet? What happens to numbers? Could I ask maybe Bianca, if you don't mind? Like, how are these numbers changing as we go further in the alphabet?
They increase in value.
Yeah, they keep increasing in value, right? So to figure out if a string's characters are in alphabetical order, what we could do is just check to see, is each character greater than the one behind it, right? So let's go ahead and get started on this one together. We could maybe go to our terminal here and code up alpha.c. And this will be our new file. I'm not downloading anything, just making a new file here. And we could say, I want to include the CS50 library. I want to include standard.io.h to print things out. And I want to have this main function still, this main part of my program. And now what I could do is I could say, I want to get some string from the user. So I could say string, maybe word, is going to get what? What kind of function could we use to get a string from the user, from the CS50 library? Maybe Alina, do you have any thoughts here?
I'm sorry, I'm not sure.
That's okay. We're trying to get a string from the user here. So how could we, what kind of function in the CS50 library might be useful for us?
Get string.
Yeah, get string, right? So we could say get string, and maybe in this case, enter a word. And the rest of our program, I might leave up to you. But again, the goal is to check if a lowercase string's characters are in alphabetical order. And if they are, print yes. If they aren't, we'll print no. And you might want to have some kind of loop that goes through every character and does that check for you, checking to see if each character is kind of more than or less than the one behind it, and making a decision based off of that to figure out if it's in alphabetical order or not. So I'll go ahead and paste this one in the chat for you all, but any questions before we begin here? Not seeing any. I'm just finishing typing in the chat. And you might find ASCIIchart.com useful to go ahead and take a look at these, the representation of these characters as numbers in this case. So we'll go back into some breakout rooms for, let's say, about 5 minutes. We'll come back afterwards to do this together and then talk more about command line arguments in the end. So let me go ahead and open these up. And I'll see you in a few. All right, welcome back, everyone. Again, I hope you made at least a little bit of progress or you learned something while you were working on this. This one is a little bit more on the advanced side. So what I thought what we'd do is take a look at a solution together, kind of walk through what it does and see what questions come up as we do so. So here is one way of approaching this problem. I can zoom in a little bit here. And what we'll do is we'll first get our string from the user on this line 7, and then we'll go ahead and figure out how long that word is. Now, what we'll do is we'll go through every character kind of front to back and say, OK, let's check if the character is not alphabetical. Often in computer science, it's easier to check for something that if it's not true, then it's check for something if it is true. So here we're going to say, I want to see if it's not alphabetical. And if it is, I want to go ahead and print no, it's not alphabetical, and return 0, meaning I'm going to exit my program. Nothing else will happen here. But assuming I actually get through this loop all the way through, I'll go ahead and print yes. And the key kind of intuition here is that we know if something's not alphabetical when the current character has a value that's greater than the character that's before it. So here, if I were to example, say, look at, actually, let me take a, yeah, before the character that is, yeah. So here I would look at B and say, OK, B in this case is greater than A. If we look at that chart from earlier, let me go back here, open this up. We could see that B is 98 and A is 97. So in this case, if we ever find that this number, this character here is greater than the character ahead of it, we know that we've found a non-alphabetical sequence. And we can go ahead and say no in this case. Assuming we get all the way through, though, and we don't ever trigger this, and we don't ever end our program early, we could, though, assume that everything must be alphabetical and thus return 0 at the end. So questions on this or places you were getting stuck as we were going through? Yeah, Dewey.
You don't need the return 0 at the end, right? Like after the print yes. You need it for the print no, I think, but not the print yes.
Yeah, we don't technically need this here. Maybe it's good for completeness' sake to have some return value there, but C will kind of automatically return 0 as soon as you hit this kind of bottom semicolon of your main function. The return 0 here, though, as you said, is necessary because it ends our program early and keeps us from printing no, 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 no as we go through our program, right?
Could you
Other
explain
questions?
could you explain one more time how you need to do string length as the first, like at the top?
Oh, yeah, like up here? Yeah, well, so in general, when you want to do something for every character in a string, you generally want to have some form of strlen. And strlen is going to tell you how many times you should loop in your for loop. So here, for example, if I wanted to figure out how do I do something for every character in my array, well, I have to know how many times to loop, and thus I have to know how long my string is. So I know I need strlen to figure that out for me, and I can use that variable in my for loop later on. Does that make sense? Nice. OK, other questions here too? All right. So not seeing any there. So let's go ahead and move on to some command line arguments just to wrap up our section today. I know there was some excitement around command line arguments. They're pretty cool, actually. You can actually use them to modify our program behavior as we type it in at the terminal. And so maybe you're used to using a GUI or a graphical user interface, but you'll get used to, as you do more programming, using this terminal interface. You can type in a program's name and then go ahead and give it some options to run with. And we saw Clang earlier, this compiler for the C language. And Clang does take some command line arguments. So we saw it could take this command line argument called mario.c. And this is a command line argument because it's given to the program at the terminal. It's not an option we give to a program as it's running. It's given to our program before it runs. We could also give more. We could say the output of this compiler should be Mario, this file called Mario. And even make itself takes command line arguments, that Mario right there at the very end. And we could even have another program called initials, for example. Actually, no, I think we'll get to initials in just a minute, sorry. But the intuition behind command line arguments kind of comes from this idea of these functions that take their own arguments. So in an earlier problem, you maybe saw this calculate quarters function. And here, this calculate quarters function takes this argument called sense, right? And this program or this function takes that input and then does something different because it's given that input, this argument over here. Similarly, in our programs, we have this main function where this is the function that gets called as we type the name of our program into the terminal. So if I were to type maybe ./Mario, again, my main function is being called. Now, Mario didn't take any command line arguments. And because of that, we typed int main and void, right? Where void says no input to our program is given at the command line. We do return something from this function, an integer, kind of like a status code that we saw in lecture. But the input to this program is void, is currently nothing. If we did, though, want to give our program some input it could run with, typically in our programs, we would write something like this: int argc and string argv. That's an array. And the reason we do this is we often want two pieces of information as our program starts. We want to know how many arguments were given, and that's argc for argument count. Notice how it's an integer called argc for argument count. That's how many arguments we've given at the command line. And we're also given this array of those arguments called argv, which stands for argument vector. And so argument vector, argv, is this array of strings that have been given to our program at the command line. And we can use those in our program to kind of modify its behavior. Now, for example, if we were to go in and make our own kind of program here, I could do maybe code CLA for command line arguments. And I could then do all the usual stuff. I could include standard IO.h. I could include maybe CS50.h. And I could do int main. But this time I want to take command line arguments. So I could say int argc string argv. And what this will do for me is allow me to figure out what else was typed along with my program. And to do so, I might do the following. I might try to go through every element of this argv array. So I could say for int I is 0, I is less than argc, I++. Let me loop through every argument I've been given here. And then go ahead and print out as a string whatever's inside of argv at that location here. Let me fix this. And let me just make it a little clearer here even too. I could say maybe argc is, and then some number, and argv is, or sorry, argv, let me actually make this clear. So we could say argv bracket, whatever we're currently looking at is whatever's inside of argv. So here, when I run this program, I'll see argv bracket 0 bracket 1 is whatever's at that location here. So I'll then go down my terminal. I'll compile this. I'll say make CLA, and I'll run ./CLA. And now I see argv bracket 0 is ./CLA. But if I did ./CLA, maybe Carter Zenke, well, now I see more. I see argv bracket 0 is ./CLA, argv bracket 1 is Carter, argv bracket 2 is Zenke. So I've been given this array that contains everything I typed in to the terminal here. And just to make this even clearer, I could go back to this kind of diagram over here. When we type make Mario, that very first make over here is argv bracket 0, the very first element of argv, or argument vector, or argument list. And argv1 is that second element there we can get using our program here. And often that you'll see when you write your own programs in CS50, you might want to maybe kick off your program with some number. Maybe in Caesar, you might type a number to help us figure out how much to rotate a certain cipher and so on. And this is helpful for actually making our programs change behavior as we go through. So just wanted to pause here and ask for your questions on command line arguments. Maybe you've tried them already, maybe you haven't, but what questions do you have about why they're used or how we use them? Okay. So seeing none so far, let's go ahead and try to do a bit of brief exercise together here. We want to write this program called initials, where if I were to run it with some command line arguments, I would get back the initials in the certain name here. So here I would get back CZ, for example. And notice how we have, again, this argument vector that has every element inside of it. And if we want to access individual characters inside of these strings, we could just have another bracket notation appended. We could say argv bracket 1 bracket 0 gives me that very first element of that second element in our argv. And similarly, argv bracket 2 bracket 0 gives me that very first element of that third element inside of argv. So we're kind of nesting these arrays as we go through. And towards that end, let's try to actually implement this program together. So we'll go over to our terminal here and type code initials.c. And I'll do all the same stuff. I'll do include cs50.h. I'll do include standard.io.h. And finally, I'll do int main, not void, but int argc and string argv. And I want to eventually do something like this, /initials Carter Zenke. So let's try printing out first this very first C. How could I print that piece out? Could I ask maybe McKenna, if you're feeling up for it? How could I try to print out that very first C here?
Wouldn't you do like printf, like something having to do with like the like argc bracket 1 bracket 0, right?
Yeah, totally. So we want to print out a character, right? So we'd use this format code for a character like %c. And now I have to say, okay, what goes in this placeholder here? And we could do the following. We could say, well, I know I want to look inside my argument vector, this like list of strings I've been given. This we know is that very first one. So that's like argv bracket 0. This one is argv bracket 1, which is getting us closer, right? But we don't want to print out the full name here. So if I were to do this, for example, print out a string, let me do make initials and then run it in just a minute. Oops, let me add a semicolon. Make initials. Do /initials. Whoops. /initials Carter Zenke. Notice I get back the full string Carter, but I don't want that. I just want the actual first character. So I could then, as you were saying, we kind of go ahead and say bracket 0 to get that very first character in there. And I'll go ahead and add a \n here. So I'll say make initials, run initials with Carter Zenke, and now I get back C, which is nice. But maybe to finish things out, could we go to Bianca, if you don't mind, maybe figure out how we could get that second initial here?
You would do like the same thing like that we have instead of the 1 and the 0, you would do like 1. Well, the first one, is that from the Carter or is that from your last name?
Yeah, so this one here, if we yeah, so when we ran this is from trying to get this initial C here, right?
Yeah.
So now I want to get the Z.
Okay, so got it. Okay, so you would do kind of the same thing, like, but instead of argv1 and 0, you would do 2 and 0.
Yeah, 2 and 0. And the reasoning here is that we're going to first index into that argument vector, this argument list here. And here we're going to get that third element. This index of 2 gives us the third element. And then within that, within this string here that is also an array, we're going to get that very first element. So we'll go to the Z here. And if we do this, I would try to maybe make initials, and then I could do /initials Carter Zenke. I would see C, and then I would see Z. So there's much more to this if you'd like. You can maybe use a loop here to go through and do multiple command line arguments, but I think for now we'll leave it here. This is going to conclude our section officially. It was wonderful to spend time with you all today, and this was CS50 for now. There are also going to be labs, tutorials, and office hours this week, so make sure you go to all of those to get help as you need it. I hope this was helpful for you. I'm looking forward to seeing you all throughout the term. And again, thank you all for joining us on Zoom today.